All right, so this is University of St. Thomas, Math 005. This is lesson 1, and I'm working on part 8 here. Hopefully these are going to be helpful as you go through filling out your in-class lessons and your required questions. So hopefully this will be helpful. I want to make sure that we're figuring out how to cancel. We've already talked a little bit about that already, but I want to make sure that folks are feeling comfortable with it, both when we have a single fraction and then when we're dealing with reducing fractions that are already, you've got a multiplication or division going on. So let me go ahead and we'll walk through this. I'm going to say I have 3's hiding in both of those. And then 3 times 9 is what would give me 27. So I have 3 times 3 times 3. And here I have a 3 times 3 times 4, right? Because 3 times 4 is 12, and then times another 3, that's going to get me 36. So I can go ahead and cancel anything that has the same number. All right, so I'm going to have here, I have a 3 over 3, which is the same as a 1. Here I have a 3 over 3, which again is the same as a 1. And I'm left with a 3 over 4. So my solution here is 3/4. All right, in this case, I want to go ahead and I'm going to go back to my blue. I have my 50, which I'm going to say 5 times 5 times 2. And then my 75, again, that's going to be a 5 times 5 times 3, right? And then I'm going to go ahead and cancel. 5 over 5 is a 1. 5 over 5 is a 1. And now I'm left with 2 over 3, and 2/3 is my solution here. All right, let me talk a little bit about multiplying fractions. Multiplying is about as easy as it gets with fractions. If I have, let's see here. If I have 1/8, and I'm multiplying that by 2 over 30. Oops, 2 over 30. I could go a couple of ways with this. I can cancel my 2 with the 30, right? Or I can cancel the 2 with the 8. So I can pull this apart a little bit. I'm going to initially write it just as the multiplication. So it's 1 times 2, and then I've got 8 times 30. Now I'm going to break this apart a bit. I'm going to have, again, my 2 is just going to stay in the numerator. And now I have a 2 times 2 times 2. That gets me my 8. And then that's multiplying 3 times 2 times 5. And that's going to get me my 30. All right. And if you take a look, I have a 2 and a 2 I can cancel. So let me go ahead and do that. All right. Now, what I have left is going to be my answer. I have a 1 in my numerator, right, because I've canceled that with one of the 2's in the denominator. So now I've got 2 times 2 times, I'm going to move this 2 over, so it becomes a 2 times 3 times 5. So I'm going to wind up with an 8 times 15, right? So I have 1 over 8 times 15. And that's going to give me 1 over 120. And that would be my answer. Now, if you notice, all we did was we canceled what we could, and then we multiplied across. Now, if you had multiplied across and then canceled, that's fine too. There's nothing wrong with going either way. Now, I will say that I personally find it easier to make certain I've got all of my canceling done as much as I can before I go ahead and multiply, because that makes my numbers smaller, and it's a little less daunting that way. So I'm going to go ahead and do another problem here. Let's do 8 over 9 multiplying 3 over 4. All right, I'm going to scroll this up just a bit so we have a little more room. All right, so here, if you take a look, I have a number of things that I can cancel. All right. I'm going to kind of break it apart. I'm going to not take it all the way down to primes, but I want to show where these numbers are coming from. And then maybe on the next one, I'm not going to break it apart. We'll just go ahead and cancel. But I want to make sure folks understand here what's happening. Okay, well, I know I have a 4 in the denominator. And I know that I have a 4 hiding inside of this 8. So I've got a 2 times 4 happening here. All right. And then I have a 3 that I'm multiplying. And then I have 9, which is 3 times 3. All right. So now let's go ahead and cancel what we can. Now, if you had broken it down all the way to the primes, that's fine. It wouldn't change anything except how many times you have to cancel. But here I have a 4 and a 4. So those 4s are gone. They became a 1. This 3 and this 3 became a 1. What have I got left? I've got a 2 over 3. And that's my solution. That's my answer. Okay, now, in breaking this apart, it was pretty clear that I could cancel some of this stuff. Sometimes it's not going to be quite so evident. Other times it will be very easy. And it's just fine, instead of going ahead and doing something like that. Let's go with something like this. Let's go with 5 over 9 times 27 over 35. All right, so in this case, I can see I have 5s, one in the numerator, one in the denominator, right? Even though we're multiplying and they're technically in 2 separate fractions at this point, when we're multiplying them, it's going to be the same as though we had broken them apart, or we'd kind of smushed them all together into one fraction. So we can go ahead and cancel here. I'm going to take advantage of that. I'm going to cancel one of my 5s. This is going to become a 1. And this is going to become 5 times 7. That means when I cancel that 5, it becomes just plain 7 here. All right. I have a 9 in my denominator and a 27 in my numerator. So if I take a 9 and divide it into the 27, right, I could say 3s, but I know that there's a 9 times 3 is going to give me 27. So I'm going to go 9, cancel that out with a 9 times 3. That means I have a 3 left here. And this becomes just a 1, right? We have a 1 over 1, which is just 1. And then I have 3 over 7. And there's my solution. Now, again, if you feel more comfortable breaking it apart and then canceling, do it. I am not in any giant rush for people to complete their work. I would rather that you get the problem correct and take a little more time to do it than trying to rush through it and mess yourself up. All right, so let me do another video here talking about division in just a moment. I'm going to end this right now.